Before we get started on section 4.1, I want to look at an example, a real life example. Here in Houston, we've had some flooding recently, and here we have a kind of a graph of the river levels of the San Jacinto River near Humble, Texas. And I want to just look at the graph and talk about the increasing and decreasing intervals here that we see. So first of all, the river, looks like here we start out on May 26th at 9 a.m. The river looks like it's pretty level here at 43 feet. And it stays level. It stays constant, in other words. So what we see here at this particular spot, we have a constant interval. It's constantly 43 feet. And it's represented here, it looks like by a horizontal tangent line. Okay, so when we're constant, looks like it would have a horizontal tangent line. Okay, that makes sense. Constant interval. Now, it looks like at some point on May 26th, it starts to increase. So notice that the river starts to go up to 45 feet, 47 feet, and continues to increase. And then by Saturday, it looks like Saturday at 9 a.m., it's above 57 feet. And it continues to rise, continues to rise. It looks like it maxes out at about 61.8 feet. So what we see here is that the function, or the graph, is rising as we move from left to right. So think about the tangent line for each of those points on the graph. The tangent line, that line slants uphill. So it's increasing. Think about all the tangent lines. If I draw a line through one point on the curve, all those tangent lines have what we would call a positive slope. So it's rising, rising, and I call this a maximum. Okay, why would I call that a maximum? Well, that's the highest that the graph goes. At some point, what happens when we reach a maximum, the graph kind of levels off at some point. So at some point, the river stops rising and stops falling. It just kind of remains constant for a little bit of time there, and it maxes out, looks like at 61 feet. So it maxes out kind of at the top of that graph. Well, in order for it to max out, what does it have to do? It has to start coming down. So what we notice is that the graph starts to go downhill as we move from left to right. So we're going down. Okay, it looks like it gets closer to the normal level of the river. Now let's think about what happens with all of those tangent lines. So all of those tangent lines, if I draw a line going through one point on the graph, all those tangent lines are slanting downhill, and all of these have a negative slope. Alright, so we want to think about increasing have a positive tangent slopes, decreasing, when the graph is decreasing, we have a negative tangent line slope. Alright, where the graph is constant, the slope for constant intervals, okay, so we have that horizontal tangent line, the slope in this case would be 0. There is no rate of change. No change. Alright, so I just wanted to give you kind of an idea of what we're going to be looking at in this section with a real life example.